Okay, AP, today we're going to do section 7.2 in the pre-cal trig expression unit. So just copy it down as is in your notes. It's called verifying trig identities. To verify a trig identity, you're going to transform one side of the problem into the same form as the other side. You can work on one side at a time, or you can work on both sides. It kind of depends on the problem and what you see first, which side you think is the easiest. That's what I usually do. To back up for a second, when we're verifying the difference in this section from the last section you were simplifying trig expressions and you were trying to get used to the reference sheet, and there was only, it was an expression, so there was no equal sign, and you're just trying to get it, like I said, down to the simplest terms you could. And in this section, it's verification. And so basically there will be an equal sign in every single problem. And you're trying to verify, is it a true trig identity or not? And so basically you're trying to transform it into the same thing on each side. So look at the suggestions for verifying. One suggestion is what I said a second ago. You're going to transform the more complicated side of the equation into a simpler side. Second suggestion is to substitute one or more basic trig identities to simplify. You can factor. You might have to multiply to simplify expressions. You can multiply an expression by an expression equal to 1. Sometimes you'll have to be very creative in the ways to kind of get it to simplify down to so it equals the other side. And then another suggestion is and I do this a lot. I try to express all trig functions in terms of sine and cosine when possible. Okay, so what my suggestions are, you can work on one side at a time, or you can do both. That's up to you. I always go with the more complicated side of the equation first, and then I'm going to use my reference sheet until I get it down into simplified form. Sometimes you'll have to factor or multiply. And then, just like I said before, just try your best to get it in terms of sine and cosine when you can. Another thing you need to make sure that you write down is I don't want you using or transposing, because that will throw you off. So please do not transpose quantities from one side to the other. You're not allowed to do that in a verification problem. Okay, let's see how we're going to think about this. So question number 1 says the cosine of x times the secant of x is equal to 1. So we're trying to verify that this is an identity, and if it's a trig identity, going back to the first section of notes from like last week, a true trig identity means no matter what value, what angle you put in for x, the cosine of the angle times the secant of that same angle will have to equal 1 every time. If it works for all angles, it's a true trig identity. Okay, so again, we're just trying to verify. We're not trying to select a value or anything. So what I would do is I would start with the more complicated side, which is the left. This one is fairly straightforward. I hope that you can see that as we go through. The secant is the reciprocal identity of cosine, so I'm going to switch it over. So I chose to change secant to cosine terms. And then I'm looking at this as a fraction, so again I didn't move anything to the left or the right. I have to kind of keep the equal sign where it is. Sorry about that. Keep the equal sign where it is and simplify as best I can. Alright, so there's my equal sign, there's my 1. Then cosine times 1 is cosine x, and then on the bottom I'm going to end up with cosine x. And so obviously that any expression divided by itself is 1, and so I always just put a little check mark at the end to show that I'm finished and I verified it. Okay, we'll move to example 2. And I notice that I'm going to find my equal sign, go ahead and drop that down. This side, the first side, is definitely more complicated than the right side, so I'm going to start on the left. Okay, let's see. One thing I notice is that these two quantities are being multiplied together, Whereas, and I also see a subtraction sign. So I think I'm going to, my eyes are drawn to that tangent and cotangent. So I'm going to put a big bracket here to kind of keep these separated. But I'm going to drop my tangent down, and I'm just going to change my cotangent over to 1 over tangent. And then drop tangent squared down. Okay, so now I'm left with secant squared x minus, and again, this type of problem right here is the same as the example 1. The tangents are going to cancel for me if I want to go ahead and see that. It's just multiplying straight across, so it's basically tangent of x over tangent of x. Well, that's going to be 1. And then secant squared x minus 1 is equal to tangent squared x. I'm going to go to my reference sheet, and I notice that at the bottom, underneath that Pythagorean identity section, there, the second one, I'm going to jot it down here, says the tangent squared theta plus 1 is equal to the secant squared theta. So this is a Pythagorean triple. And recall from the last set of notes that I said you could take, excuse me, any of those and you could transpose them, and these are identities. So you could kind of manipulate them into and form different types or different forms of them. So, sorry, I got tongue-tied there, messed that up. But anyway, your job is to kind of look at this one and transpose over. If you can see that, we got a tangent squared theta is equal to the secant squared theta minus 1. Okay? Alright, so that's exactly what I have in my problem. And so what I can do right now is either I can change this over to tangent squared, or I actually could change this over to secant squared minus 1. One is really not better than the other. It honestly just depends on what you want to write down. As long, you'll know you're correct in this section and successful, and basically accomplish the goal when the left side of your problem is exactly identical to the right side. That's when you can stop and say, yes, I verified that identity. Okay, let's go to number 3. Question 3 is 1 plus tangent squared x divided by the cosecant x times secant x is equal to tangent x. And the left side is definitely more complicated. So, I'm going to start there. I'm going to drop my equal sign down. I'm going to drop my tangent down. Jump over to the left side, and then I see that same identity. They like to use the same ones. 1 plus tangent squared, and that's equal to secant squared. So I'm going to go ahead and change that over right now. See if that helps me. Let's see. Let's go to the denominator. I see cosecant and I see secant. I'm going to try to get it in terms of sines and cosines if I can. So I'm going to switch this over to 1 over, or cosecant's the same as 1 over sine. And secant is the same as 1 over cosine. Okay. And on the bottom, that's going to be 1 times 1 is 1. And sine times cosine is sine cosine. Let's try that again. Sorry. So sine and cosine x. Alright, so now we are going to try to simplify. Let's see. Secant squared x over 1 times the sine x and cosine x over 1. And basically all I did right now is I inverted that and multiplied straight across. Okay. Alright, and next, let's see what we can do. Let's see, secant squared is the same thing as 1 over cosine squared. I don't know if that will help me, but I will write it down. And I'm going to not write divided by 1 because that really doesn't matter. Let's see if this is going to work for me. I guess I will put that over 1. Okay, now I have the sine x cosine x on top over the cosine squared x is equal to the tangent of x. Oh, I like that I see a cosine to the first on top of cosine to the second. So that means like this one is going to cancel with one of these. Okay, so picture there's 2 here. It's going to cancel with 1. So now I'm left with sine x on top sine x on top divided by the cosine of x. There's only one cosine left. And that looks really good because now I'm going to draw a big arrow. The sine, we know the definition of sine divided by cosine is tangent. And so I have finally made it to the point where I can say, yes, the original problem is definitely a true trig identity. I just showed the left side is equal to the right side. Okay, this is just a more complicated version of an identity. There is an infinite number of identities, guys. There's no possible way we can memorize all of them. So that's why they usually ask you just to narrow it down and memorize the ones like I gave you the first day. Like just memorize those, and then you'll have a really good tool set where you can simplify others and then find others on your own. Let's see here. Number 4. Okay, I see a fraction equal to a fraction. Remember my comment about you can't transpose, like you can't move one term to the other side in those suggestions? Well, one thing you can do is when it's a proportion problem, as is the case here, when you see like fraction equal to fraction, you are allowed, this is allowed, you are allowed to cross multiply. And the reason I'm thinking that might be the best bet here is because like if I look, I probably should have done this first. If I looked at the top right here, there is no identity on this reference sheet that stands for secant x plus 1. Likewise, there's nothing on the reference sheet that stands for secant x minus 1. Okay, tangent, the only thing I could do there is change it to sine and cosine, like sine over cosine. But if I did that, it would be like fraction divided by fraction. And I'm not sure that it might make it more complicated. So because I don't see up front anything that's kind of jumping out at me that I can simplify off the reference sheet, and mainly because it's a proportion, I'm going to use algebra skills and cross multiply. So I'm going to do like secant x plus 1 times secant x minus 1. I'm going to do FOIL method. So secant times secant is secant squared. Outside would be negative secant x. Inside would be positive secant x. And last would be negative 1. Okay. And then, oops. And then on the second side, it's going to be tangent squared x. Get rid of this this division bar, because I did not mean to do that. And so now I see that secants are going to cancel for me. I have secant squared x minus 1 equals tangent squared, and that is, for the third time today, the same type of identity. So this definitely is equal to the tangent squared. And check. I just verified that it does work. Okay, on these types of problems, it may take you a few days to kind of get the patterns in your head, but it really does take a lot of practice. It's like puzzles. You heard me say that in the first section. So just be patient with it. Try your best not to get frustrated. Some problems are easier than others, and we know that from our past math history. Just hang in there, keep trying, and just know there's always more than one way to do it, and it's really up to you what you see first, and you'll go with it and hopefully simplify both sides to make it make it work.